reality is far stranger than fiction. The deeper you dig into mathematics and the universe, the more you find things that sound completely made up, yet have been proven beyond any doubt. So here are 10 facts that seem impossible, but are absolutely, provably true. Let's count them down from 1 to 10. Number 1. Pi never ends. We've now calculated it to over 100 trillion digits, and no matter how far we go, it never repeats and never falls into a pattern. But here's the part that feels almost magical. Pi isn't really about circles at all. It appears in the physics of waves and vibrations. It hides inside the bell curve that describes randomness and statistics. And in the 1700s, a mathematician showed that if you drop a needle on a lined floor, the probability it lands across a line involves pi. Drop enough needles, and you can actually estimate pi without ever drawing a single circle. Pi seems to be woven into the deep structure of mathematics itself. Number 2. Gravity is not actually a force, at least not the way we usually imagine it. In Einstein's general relativity, mass and energy bend the very fabric of space and time. Picture a heavy ball on a stretched rubber sheet. It creates a dip, and anything rolling nearby curves toward it. That's what the sun does to space, and it's why the planets orbit. The Earth isn't pulling you down with an invisible rope. It's warping the space around you, and you're simply following the straightest possible path through that curved space. And this bending is real and measurable. Starlight passing the sun gets deflected, and without correcting for curved space-time, your phone's GPS would drift by kilometers every single day. Number 3. Near a black hole, time itself slows to a crawl. A black hole is a region where gravity is so extreme that nothing, not even light, can escape once it crosses the boundary called the event horizon. And because gravity warps time, the closer a clock gets to that edge, the slower it ticks. If you watched a friend fall toward a black hole, you would never actually see them cross the horizon. Their image would slow down, turn red, and freeze at the edge, hovering there forever from your point of view. But from their own perspective, they'd fall straight in. And the tidal forces would be brutal, stretching them into a long, thin strand. Physicists actually call this spaghettification. Number 4. Some infinities are genuinely bigger than others. This sounds like nonsense, but the mathematician George Cantor proved it in the 1800s, and it shook mathematics to its core. The counting numbers, 1, 2, 3, and so on, are infinite. You'd think nothing could possibly be bigger than infinity. But consider all the numbers between 0 and 1. Cantor showed that no matter how you try to list them, you can always construct a brand new number that differs from every single entry on your list, just by changing one digit at a time. So those numbers can't be counted, even in principle. They form a larger infinity. There isn't just one infinity. There's an endless hierarchy of them, each bigger than the last. Number 5. Doubling will fool your brain every single time. There's an ancient legend about the inventor of chess. When the king offered him any reward, he asked for something that sounded almost insulting in its modesty. 1 grain of rice on the first square of the board, 2 on the second, 4 on the third, doubling on every square. The king laughed and agreed. But doubling is deceptively powerful. By the 20th square, you're already past 1,000,000 grains. By the 40th, 1,000,000,000. And by the 64th and final square, the total comes to more than 18 quintillion grains of rice, more than has ever been grown in all of human history. This is exponential growth, the same math behind pandemics, compound interest, and computer chips. Number 6. Many mathematicians consider this the most beautiful equation ever written. E raised to the power of I times pi, plus 1, equals 0. At first glance, it looks like a jumble of symbols, but look closer. In one short line, it unites the 5 most fundamental constants in all of mathematics. 0, the foundation of counting. 1, the basis of multiplication. Pi, from geometry and circles. E, the natural number of growth and calculus. And I, the imaginary unit. These numbers come from completely different corners of math, discovered centuries apart, yet they fit together perfectly using only addition, multiplication, and a single exponent. There's no reason they should be related at all. The fact that they are feels like a glimpse of hidden order. Number 7. Mathematics loves to hide perfect simplicity inside terrifying complexity. Open any advanced textbook and you'll find expressions that look monstrous. Double integrals, infinite sums, symbols stacked on symbols. You'd expect the answer to be some ugly, never-ending decimal. But again and again, the chaos collapses into something astonishingly clean. There's a particular double integral, the kind that takes a full page of work to evaluate, and after all the dust settles, the answer is exactly the natural logarithm of 2. Not approximately. Exactly. A messy, intimidating expression resolves into one of the simplest constants in mathematics. Moments like this are why mathematicians fall in love with the subject. The feeling that beneath all the complexity, the universe is quietly, stubbornly elegant. Number 8. Space is constantly firing bullets of pure energy at the Earth. They're called cosmic rays, subatomic particles racing through the universe at almost the speed of light. Most are harmless, but every so often, something extraordinary arrives. In 1991, a detector in Utah recorded a single particle so energetic that scientists nicknamed it the "Oh my God" particle. One tiny speck, smaller than an atom, carried roughly the same energy as a baseball thrown by a professional pitcher. To do that, it was moving at more than 99.9, followed by many more 9% of the speed of light. And we still don't fully understand what cosmic engine, what exploding star or monster black hole, could possibly hurl one particle with that much energy across the universe. Number 9. The North Star is not permanent. We think of Polaris as a fixed point, the one star that always marks true north. But the Earth doesn't just spin on its axis. That axis itself slowly wobbles, exactly like a spinning top that's beginning to lean. This wobble, called precession, traces out a giant circle in the sky, and one full loop takes about 26,000 years. That means our pole star is only temporary. Around 5,000 years ago, when the pyramids were built, the North Star was a different star, called Thuban. And in roughly 12,000 years, the bright star Vega will take the title. The night sky you see is just a single frame in an incredibly slow cosmic movie, set by the turning of a planet-sized gyroscope. Number 10. Your brain literally cannot picture how big the universe is, and that's not a failure of imagination. Let's try anyway. If you shrank the sun down to a single grain of sand, our entire Milky Way galaxy would still stretch across an area the size of a continent. And the Milky Way is just one of an estimated 2 trillion galaxies. Put it all together, and there are more stars in the observable universe than there are grains of sand on every beach on planet Earth. Then comes the strangest part. Everything we can see, all the stars, planets, and galaxies, makes up less than 5% of the universe. The other 95% is dark matter and dark energy, things we can measure but cannot see or explain. We are a tiny, glowing speck inside something almost unimaginably vast. 10 facts, and reality still wins every time. The universe is stranger, bigger, and more beautiful than anything we could invent, and the strangest part is that we can actually prove it, with nothing but logic and curiosity. If this rewired your brain even a little, you'll love the rest of the channel, where we make the biggest ideas in science and math finally click, one clear visual at a time. Thanks for watching, and we'll see you in the next one.